Yeah, what is to understand what we are doing? Some words. What is code coverage? So code coverage means that when you have a code, that everything is executed during the test. When you do the test, that all parts are executed. And when everything has been tested, you have then a code coverage of 100%. But the question here is, what is everything? So from a normal understanding, we could say that when every statement of the code was executed during the test, um, we have tested the code. That means that there is at least one test for every statement, and this is statement coverage. So every statement has been touched by the test at least once. So this is not a very deep coverage level, but there is only which is even simpler than that. This is function coverage. Oops, function coverage. When you are measuring function coverage, you have only to show this, that every function of the code has been called at least once. So this measure is very simple. It does not really show what have been executed or tested inside of the function. Just you have touched it once. Then a stronger coverage level than statement coverage is decision coverage. Here in decision coverage we are looking at decisions, for example to if statements, and the question is, was the decision executed as false and was it executed as true during a test? So once false, once true. Then in theory there's another coverage level which is path coverage. This is rather theoretical. This coverage level is looking at every possible combination of the whole path through a program. So looking at all in practice, in real life, this is not of interest. Also the standards are not requesting this. So let's go back to this, to decision coverage. The next stronger level is condition coverage. So in condition coverage, it is checked, is every condition, that means every atomic part of a decision was tested as true and as false during the test. So this is a stronger than decision coverage. And one or two steps more, it's multi-condition coverage, and multi-condition coverage checks if all possible combination of true and false was testing during the test. So all possible combinations of this. So in practice here you get a lot of test cases, and there is a simplification of this, which is the MCDC coverage, the modified condition decision coverage. The result somewhere is the same, but you need less test cases, and this is the level which are requested by the standards for critical software. For example, in 26262 for ASIL D it's requested. So, and we are already here to have a look to the reasons why we do code coverage. There are first external reasons, like industrial standards, like the automotive standard ISO 26262. I think you have to handle with this, and in 26262, according to the criticality of the software, you have different levels. The ASIL A is the lowest level, ASIL D is the highest level for very critical software. When it doesn't work, then it's very dangerous. So, and we see for ASIL D, MCDC coverage is mandatory. Double cross means highly recommended in the standards, but in practice that means you have to do it. You must do it. And one cross is recommended You can do it, you should do it, but it's not mandatory. So, for example, for ASIL C, only branch coverage is mandatory, but as soon as you get ASIL D, we have MCDC coverage. So, external reason, standards. Also, another external reason might be contractual obligations, which your customer obliged you to fulfill. These coverage levels we have seen for the 26262 automotive standard. It's about the same for the other standards, for example, for railway or aerospace. There we have the SEAL safety integrity level. For example, the higher it is, desto more you need to test. It's the same everywhere. And for the highest level, we have everywhere MCDC coverage, by the way. Except the medical IEC 62304. Here only desirable to do some testing, but when you work with FDA, the Federal Drug Administration in US, they are looking very close also to the test coverage or the code coverage. So there are also internal reasons to doing code coverage. This might be part of your quality management to provide higher quality. It's good to improve the testing. So when you have a code coverage, you know what you have already tested, so you avoid redundant testing. And you know also when you can stop testing. You can stop testing when the required code coverage is fulfilled, and not when there is no more time or no more money. So